Good day, this is MTH 101, General Mathematics 1. This is for the section 11. I'll be introducing you to conic sections. Learning outcomes for study section 11. When you have studied this section, you should be able to define a parabola. You should be able to define directrix and focus of the parabola. You should be able to derive the equations for the focus of the parabola and the equation of the parabola. And lastly, we should be able to understand the equation of the target at a point. Now, what is a parabola? A parabola is a symmetrical open plane curve formed by the intersection of a cone with a plane parallel to its sides. The path of a projectile under the influence of the gravity follows a curve of this shape, and you are going to see it now after this slide, how a parabola looks like, the definition of a parabola, and how we can differentiate a parabola from a circle. A parabola is a set of points in the plane equidistant from a fixed point, which is called the focus and is represented by F, and a fixed line, which is the directrix. Now, let us consider a parabola that is symmetrical to the y-axis, as you can see on the slide. Alright, what definition can you give to a circle? Now, considering a circle, if you consider an axis and you consider a point which is your focus represented by F, a circle can easily be defined as a set of points that is equidistant from this particular point, which is your focus. Now, let's say you have this point, and that point there, and that point there, and you have it revolving around this point F. Now, you can define the circle as this set of points that are of equal distance. Equal distance. If you remember a spoke on a bicycle, that gives you a circle. Now, when you connect these points together, it gives you a circle. They have equal distance from the center, which is your focus. But in the case of the parabola, when you are talking about a parabola, it means that you are talking about a point F that is equal in distance to a line called directrix, and it's on that there. Now, if you have a set of points which form a circle with this particular axis, and you have a set of points that is of equal distance from this point to your focus and to a line, they are equal distance, then you have what is you can refer to as your parabola. They are equal distance. Now, at the end of the day, you are going to get a shape which is in form like this, where this is your focus and your line, this is your directrix. So, from your focus to the line of directrix, they have the same equal distance. So this set of points is called, connected together, is called a parabola. Now let us move on to derive an equation of a parabola. Okay, now consider an axis. Let's consider an axis, and let's consider a point F, which is your focus, Now, if this is your F, which is your point and it's your focus, and remember that we said if you have a point that is equal in distance to your directrix, let's say this is your directrix, which is a line underneath directrix. Now, if you have another point, which is your S, and it's equal in distance to this line, now, if you have a point in between your focus and your y-axis, which gives you another axis, Now, remember that this is another point, and a set of points passing through this line gives you your parabola, and joining them gives you your parabola,